Hello. Before we begin, just remember that if you have any question about math or maybe about, I don't know, maybe calculus, maybe abstract algebra, maybe linear algebra, whatever, you can just let us know through mathexperts1.com. So let's begin. Basically, let's do a quick review. Remember that if you have two functions, basically one of them is f, the other is g. So g is going from n to p, and f is going from rp to rm, and you get the composition of the functions of the two functions. That would be h. This would be the composition of the two functions. Well, the formula for, I mean, the derivative of this function is going to be a matrix. As I mentioned before, as I mentioned in another video, the derivative in many variables is a matrix. That is the reason because actually I talked about that in another video, so I'm going to leave the link in the description. But yeah, it is a matrix. And the reason because I did it first in one variable, it's because we are gonna have pretty much the same formula, but instead of multiplying numbers and get composition of functions and multiplying numbers, now we're gonna do what we're gonna have is multiplication of matrices, but it's pretty much the same. So basically, this is what it is. This is the general formula. Once again, remember that here you have a matrix and you have here another two matrices. So basically, this is the matrix, the derivative of f evaluated on g of x. This is very important. And then this is gonna be the derivative of g of x. That's pretty much. So whenever you're gonna solve a problem like that, you just need to compute the matrix of each function and apply the formula. I did it here. This is the general idea. This is the general matrix idea that you have. And basically, just don't forget that every function here is evaluated in x0, g of x0. Just that the notation becomes just too long if we specify in every single coordinate of the matrix that we are talking about f composed in g of x0.